This is practice test number 6, problem number 3, and here we're dealing with what's called the Poisson distribution. And we see the formula here at the top of the page. Your interest will be in calculating the right-hand side of this equation. The Poisson distribution gives us the probability of a certain number of events taking place in a time period when we know the average or the expected number of events in that time period. And you'll see here that the lambda is the expected number of events per unit time, is what will be how we will be using the equation. The lambda is the mean or the average number of events. We have the letter E, which is a mathematical constant, and we'll be using this value right here so that the E is always 2.71828. And X is the number of events that we're interested in, finding the probability of taking place during a certain time period. So we will assume in this problem the Poisson distribution, and in sections A and B here we are learning how to use the equation. We're told in section A that the lambda is 2.5, and we are looking for the probability that X is equal to 4. So we plug these values in. We notice that the E is to the exponent minus lambda. That's your first piece of the equation. The E is 2.71828, and you have the exponent of minus the lambda, which is minus 2.5. That's going to be multiplied by lambda to the exponent of x. The lambda is 2.5, and the x is the exponent 4 right here. And then in the denominator of the equation we have x factorial, and the x is 4, so we have 4 factorial down here. Now if we were to calculate each of these pieces individually, these are the values that we would get. The e to the exponent minus 2.5 would give us this value. 2.5 to the exponent 4 would give us this, and then we would divide by 4 factorial, which is 4 times 3 times 2 times 1, which is 24. And we multiply these two numbers here, divide by 24, and this is the probability that x is equal to 4. And we would round at the 4th decimal place. One thing you want to make sure that you know how to do is to use a negative exponent on your calculator. Some calculators require you to put parentheses around that exponent when it's negative. So you want to practice this, make sure you're able to get this value right here. On section B, we're going to use the same equation. The difference here is that the lambda is 6 and the x is 5. So we are going to do the same thing we did above. Here is our value for e to the minus lambda minus 6. That will, if we calculate that figure, this is what the calculator should give you. And then you're going to multiply that times the lambda to the exponent x, which is 5. 6 to the exponent 5, you should get this value right here. On the bottom of the equation, the denominator, we have x factorial, which is 5 factorial. And if we multiply out 5 factorial, we end up with 120. So what I did here was I multiplied these two values on top. I got this value in the numerator divided by the 120, and that gives us this value here, and we round it to the 4th decimal place, and the probability is 0.1606.